Hello everyone, in this video we're going to learn how to read binary. So while reading binary we can compare base 10 to base 2. So base 2 is our binary way of counting and dealing with numbers, while base 10 is the one that we're more familiar with, the ones that we would have used in maths before. So we use the numbers from 0 to 9, while in binary we only use the numbers from 0 to 1, or 0 and 1. So if we look at these two numbers here, using the normal way of counting, we can see that this number here is 754 and we can see that this number is 104. Now, we all know this, but one thing that we might have forgotten about is when we look at this value here, or this column, so we can imagine this as being a column. So in this example here, we can see that they're both 4. So while we were in primary school, we probably referred to these different columns with different names. So usually when we looked at this first column here with the two 4s in it, we would have called these units. And then we understand when we reach 9 here and we want to add more to it, we have to change this and we carry on 1 to our tenths. And we call this next column here tenths. And then the same happens when we have an extra field or an extra number here that we can't fit it in. So for example, if we wanted to add the number 6 to 5, we wouldn't be able to put in 11 here. So what we do is we would leave 1 and then we would carry 1 onto this next column here, which is the hundredths, and then we would increase this number here from 7 to 8. Now I think we all get this idea. But another thing we can do is, rather than using these names called units and tenths and hundredths, we can think of each of these columns as having a power. So since this is base 10, we can say that this first column here is the same as saying 10 to the power of some number. And where do we start counting? We start counting at 0. So 10 to the power of 0, we can say is this column. We can say 10 to the power of 1 is the next column here. And then we can say for the final column in this example, we have 10 to the power of 2. So if we do some quick calculations here, we can see that 10 to the power of 0 is equal to 1. Now keep in mind here that if we have any number to the power of 0, it's going to be 1. So for example, in this case, 10 to the power of 0 is 1, but it's also true that 8 to the power of 0 is 1, and that 5 to the power of 0 is 1. And when we go and look over at this example, 2 to the power of 0 is also 1. So just keep that in mind. Any number to the power of 0 is always equal to 1. Now we start to change a little bit when we get to 10 to the power of 1. So 10 to the power of 1 is the same as saying 10. So if this was 5 to the power of 1, it would be 5. If it was 2, it would be 2. Now we step it up again and we go 10 to the power of 2. So in this example, 10 to the power of 2 is equal to 100. And this is a really long way of understanding what this number is. So we all know that this is 754 and we all know that this is 104. But this example will help you because we're going to be taking the same approach when we start to learn about binary and base 2. So if we go and look at our first number here, we can see that it's 4. So we can see that this is 10 to the power of 0, which is 1. And then if we multiply this by the number here, so multiply this by 4. And then we come over here and we see 10 to the power of 1. So 10 to the power of 1 is 10. Okay. So then the number under here is 5. So we can multiply this by 5. And then if we move on to the next column, we can see 10 to the power of 2 is 100. And our number here that we're dealing with is 7. So we need to multiply by 7. So if we multiply all these numbers here, our answer we'll get is 1 multiplied by 4 is 4. 10 multiplied by 5 is 50. And 100 multiplied by 7 is 700. So if we add all these up together, the number that we're going to get is 754. This is just another way of representing it, but it's a good way to be able to understand how exactly we come to these conclusions, and it'll be really useful when we start working with binary. So this is a binary number here, okay? Now for this example, we're going to deal with a slightly smaller binary number, just for simplicity, but we will come back to this number. So if we take the number 1, 0, 1, okay, so you may have remembered from the last video that we used this number before, 1, 0, 1. This is actually equal to 5, but by looking at it, you can't really understand how it's equal to 5. So if you remember, in our base 10 system, we started off here going 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. So we're going to do a similar approach with this example, but it's not going to be 10 because we're not dealing with base 10. We're dealing with base 2 this time. So we'll get a 2 and we'll put it to the power of 0. We'll get a 2 here and we'll put it to the power of 1. And we'll have our 2 to the power of 2. So if we go and multiply these out, if we remember 2 to the power of 0 is equal to 1, because remember, anything to the power of 0 is equal to 1. Then we move on to 2 to the power of 1. 2 to the power of 1 is equal to 2. And then if we discuss 2 to the power of 2, this is equivalent to 4. So we've got our values here. Now we need to multiply them by something. So in our previous example, we multiplied them by whatever number was underneath them. So for example, if we had a number 5 here, we would multiply 1 by 5. So we'll do the exact same thing in this example. The only thing that looks a little bit strange is we're just dealing with 1s or 0. 2 to the power of 0 multiplied by 1b. So we've got 1 here, so it's going to be 1 multiplied by 1. And then this next example, it's going to be 1 to the power of 2, which is 2. So it's going to be 2 multiplied by 0. And then in our next example, it's going to be 2 to the power of 2, which is 4. So it's going to be 4 multiplied by 1. So we put 1 in here. So if we multiply 1 by 1, we can see this is going to be 1. If we multiply 0 by 2, we can see this is going to be 0. And then if we multiply 4 by 1, we can see that this will be 4. So if we go and add all these together, 4 plus 0 plus 1 is equivalent to 5. So this is how we're able to understand binary, and we can see that this number 101 is actually equal to 5.